Hey there developers, recently we've been exploring different software design patterns, and today we'll be talking about the Singleton pattern in more depth. The Singleton pattern is a type of creational pattern, i.e. it's used to create something that is then used by your code, and it is one that most developers have heard of, but it's sometimes difficult to explain why you would use one in modern modular code, due to the fact that it essentially behaves the same way as a static global variable. And as we know, static global variables verge on being anti-patterns in their own right, because they make your code less testable. So let's start with a definition of a singleton pattern and see how it fits into our development models. They usually have the following characteristics. They have private parameter-less constructors to prevent the object from being instantiated again. Static constructors are a good fit here. They are usually sealed classes, and sealed classes are restricted from being inherited, which is a way that you could invalidate the singleton pattern. They usually contain a static variable, which is a reference to the instance of the single object that has been created. And there's usually a static method, which is a way of getting the instance of the created singleton. Things to watch out for also include they need to be thread safe. So make sure that two threads trying to access or instantiate the singleton do not create two instances by mistake. So the code should therefore be thread safe. Let's put this all together and create an example of a singleton pattern. So here we have some code which I've just put together, which is an entry point for a class called Singleton Pattern. And when we construct that class the first time, we create an instance of a logger. Now, the reason why I've done this is that in this example, this logger can only exist once. It holds open a thread in the background which is used for logging, and we don't want to create two of those. We don't have the logger competing with itself. So therefore we want to have one single instance of that logger for this entire program. And this logger might be shared between different units of this program. So here we have an implementation of the singleton pattern. As you can see, we have a static read-only instance of the logger. Now this sometimes confuses people because you've got a logger within the logger, but this is the instance, the implementation of this logger class, the only one that can exist. Then we have a static logger constructor, and when that static is ever called, the first time it's called, it will create the new instance of the logger. This should make it thread safe because this is static and should only ever be called once when it's first created. Then we have a instance method which allows us to return the instance that was created when static was first instantiated. So this means that we should have, the first time this was called, an instance of this logger created, and it should never be created again. Which means that every time we call logger.instance, we will get that single instance of the logger. And that is thread safe across all pieces of code that call it. So where would you use a singleton pattern? Well, as stated, if your aim is to have a single source of truth for a given process, then that's an ideal situation. However, as an idea of global variables is repellent to most programmers because it breaks code with that external dependency, and it also breaks solid principles. Of course, singletons can be complementing dependency injection by creating a single instance of a service that might be used for the lifetime of a system and then injected into that program. For example, you might have multiple instances of classes that rely on a single underlying instance of a service, such as authentication or logging processes, and that these may not be able to support multiple instances or are configured to be only using one thread. This single instance may be then injected into other services multiple times to fulfill the code. That's a perfect example of a logger or authentication. You could even argue that the dependency injection framework itself is no more than a glorified singleton pattern, because in many ways it just creates single implementations of interfaces and then injects them into code. It really comes down to reuse. If you are reusing the same methods over and over again, but the configuration of them does not change, and you want to have a low memory footprint, then singletons are great for that. But from my own personal experience, the pattern is best suited for injecting services via dependency injection, such as loggers and services that cannot be split into multiple instances. However, even then, you need to be very careful that you don't break your own code by relying too heavily on the behavior of a singleton. Tread lightly and remember your solid principles. I hope that's helped simplify the singleton pattern for you. For more videos, please subscribe and hit the bell icon to get all notifications. Thanks for watching.